Hi everyone! Welcome back to our videos on the logarithmic inequalities. So I'm going to do another example with you guys that this time is going to use substitution and a change of basis properties. So we're starting to make things slightly more complicated. You'll see it's not that much more complicated. If you understood how to solve the equations and you understand how to deal with inequalities, especially when it comes to the interval method, this isn't much more complicated. All right, so let's get started. Looking at this problem here, we have 1 minus log base 4 of x over 1 plus log base 2 of x is smaller than or equal to 1/2. So first problem that we can see here is the fact that we have a base 4 and a base 2. So it would be ideal if we had the same base. So what I'm going to do is use the fact that I know that 4 is 2 to the power of 2. And I'm going to take the exponent on the base and bring it to the front of the log as a fraction. So on the next step, it should look like something like this, 1 minus 1/2 log base 2. So now we have the correct base, 1 plus log base 2. And that's going to be smaller than or equal to 1/2. All right, so now that we're here, this is where the substitution is going to come in and be helpful, because as it is right now, it still kind of looks sad. So let us define t to be log base 2 of x. So remember, whenever you're substituting for a log, this can be any value. So at the end, if we get negative t's and such, it's going to be all right. So what we get here is 1 minus 1/2 t divided by 1 plus t is smaller than or equal to 1/2. So if you were given this with x's, which you were in grade 10, what you would do is use the interval method immediately. So the first thing that you need to do is make the right-hand side equal to 0. So we're going to switch this one to the other side. Remember, do not crisscross. You're not allowed to crisscross. That is going to lead to mistakes later on. So if I just subtract my 1/2, then what I get is minus 1/2 smaller than or equal to 0. Now I'm going to want to make a common denominator. I think I'm already going to keep going here. So common denominator, we're going to have 2 minus t for this fraction, and then minus 1 plus t right here, all over 2 times 1 plus t. I hope you followed for that. I just made a common denominator the way you would. I'm going to simplify my numerator. So we get 2 minus 1, which should just be 1, and then minus t, which should be minus 2t. All that divided by 2, 1 plus t. I'm not going to open my brackets. You can if you want. It's not going to be very helpful. Okay, but now that we're here, that's actually pretty good. So what I'm going to do is figure out what my critical points are, which are whenever my expression here is either equal to 0 or non-existent. So either when the top is equal to 0 or the bottom equals to 0. So for that, we have 2 values. I see that we have 1/2 and that we have -1. All right, time for interval method. So we're going to go ahead and put these two values on the interval, -1 and 1/2. I just realized that I didn't do the domain. So right now it's very shameful, but I'm too tired to redo this video, and the domain happens to be very nice and easy. So just going back here, since the only argument we have is x, then it means x bigger than 0 is my domain. Okay, just keeping that in mind. For now, it doesn't really matter because these are values of t, and we said here that t can be anything. So we're not going to really think about what the domain is at this very point. All right. So we said that. So now we got to figure out what intervals are positive and negative. So I'm just going to take 0, which would be somewhere in the middle here, and plug it in. So if I plug in 0, then I'm going to get a positive over a positive, meaning that this interval should be positive and the other two should be negative. All right, since we have the smaller than or equal, we want to have these 2 intervals. So now here, don't write any answers. And yes, just like right now, these are values of t. So this step is pretty crucial. What I want you to do here is look at this interval and say, what does that mean? It means that t has to be smaller than or equal to -1 Notice I didn't write equal. A lot of you write equal signs here, but you can't do that because then you're not gonna know if you're supposed to take before or after. So just make sure you write smaller than or equal at that step. So this is going to be now a log base 2 of x. So log base 2 of x smaller than or equal to -1. Again, that's possible because we know log can have any value. So what we want to do at this point is write this side, as you've probably seen in the other videos, as a log, so that this way we can remove it. So how are we going to do that? There's different ways to do that. I'm just going to maybe talk a little bit about this point. So we want to have log base 2, because that's the log we have on the other side, of some argument, I'm going to write a for now, equals to -1. So what you could do here is just rearrange this little thing, because what we're looking for is what the argument should be. So using the definition, you get that your argument should be equal to 2 to the power of -1, right? Which is just 1/2. So the one way I would rewrite this log now that I know this, so again, this is my goal. So this is going to be log base 2 of x is smaller than or equal to log base 2 to the power of -1 or 1/2. I'm just writing it like this because I want you to notice something. It's super easy to convert a number into a log, because essentially what happens is your base and your argument are always going to match, because then that's just 1. And then your exponent is the number that you had. So what I would do if I want to do this quickly, I would say, okay, it's going to be log base b of b. You know b is 2 because it's coming from the other side. And then whatever number I had on this right side is going to end up as the exponent on the thing. Yeah, so just practice this and make sure you get it. If you don't get it, it's like really essential that you ask me. Don't carry such mistake, because you are going to need it. I hope I can erase, thank you. Because you're going to need it. You really need to understand that. So let me repeat that. If you don't understand how to convert a number into a log, please contact me by email and we can have a little Google Meet, and then we can clarify things for that. Okay, now that I'm done talking about that. You know that since your base is bigger than 1, what ends up happening is we're going to keep the inequality sign, and then we're just going to keep each of our arguments. So you get that x is smaller than 1/2, smaller than or equal to 1/2. All right, so that is the first thing that we get. Let's go do the second thing. So this is t. So t has to be greater than or equal to 1/2. So log base 2 of x is going to be greater than or equal to 1/2. Now again, we got to write this 1/2 as a log. So like I told you earlier, what I'm going to do is I'm going to write log base b of b, where the base is 2 because that's the log on the other side, and then take this number and put it on up there, 1/2. So 2 to the power of 1/2 is just square root of 2. So what's left, since your base is bigger than 1, you keep your inequality sign and you bring each of your arguments. I said this is square root 2, and this is our second part. Okay, now we got to put this together, okay? And then we got to take in consideration that our domain is x is bigger than 0 on top of that. I'm going to put all of this in the number line and see if we can make this work. Okay, so we've got in order 0. Square root 2 is about 0.5 something. So no, not at all. It is 1 point something. So this is going to be 0.5 comes first, and then square root 2 comes second. Okay, so let's see. So in any case, we need everything to be bigger than 0. So I'm just going to put a huge arrow here. So if there's anything that comes before that, no good. Then it has to be smaller than or equal to 1/2, meaning that it has to be this interval here. So we're going to need this. And then after that, it has to be greater than or equal to root 2. So this interval is also going to work. So our answer is going to be x is going to be between 0 excluded to 1/2 union. 1/2 should be included, right? union square root 2 plus infinity. All right. I hope that makes sense. It was a pretty challenging problem. Let me know if you have any questions. Bye, guys.